Hey everybody, this is Mr. Chernetsky and this is Unit 2.2, Lesson 1, Triangle Congruence. Now we talk about congruence in general, or just in generally in polygons. I could be talking about some sort of quadrilateral. Basically what we mean to say that something is congruent, and we use this symbol of an equal sign with a little squiggly, that means congruent. But if we have two congruent, say quadrilaterals, what we mean is every corresponding side is equal. And you notice I'm indicating that with little tick marks here. So this single tick mark and that single tick mark match up, and the two match up. So every single side, corresponding side, has to match up, as well as every single corresponding angle. Okay, so congruence means all corresponding sides and angles are congruent. Now in triangles, we only have three sides and three angles. So all matching sides have to be congruent. So AB and DE have to match up. But it's also all the corresponding angles. So, for example, A and D have to match up. And if that's true, we can make a congruent statement. A congruent statement is just a statement of what two triangles are congruent. And we write it like this: triangle. Now the order doesn't matter however I start out. I could do ABC, or doesn't matter which initial letter I start out with. But I make that statement, and then I put my little congruent symbol to triangle, and I have to be very careful. I have to match up corresponding letters. So A matches with D. So D goes first. B matches up with E. So E would go in the middle, and C matches up with F. So it goes by what matches up. It does not go by alphabetical order. It just so happens that the triangles were labeled that way, that the alphabetical order match up, but that is not necessarily the case. Now, finding three pairs of congruent sides and three pairs of congruent angles, that's 6 things. That's quite a bit to determine congruence. So luckily for us, there are some shortcuts in triangles. We don't have to know all the angles and all the sides are congruent to know that triangle's congruent. Our first shortcut is called side, side, side. So if you actually click on this GeoGebra link in your notes, you should be able to pull that up. This should open up this GeoGebra. And basically what I've done here is I've made a copy of all three sides. So the green, here's my original triangle. I made a copy of it down here, that length, and I can demonstrate that to see how it matches however long the original green one. The copy is the same. Same with the blue. The larger, smaller, the original blue side, this blue length is the same. And same with the red. So I can make that red bigger or smaller. Now when I actually try and connect these, you'll notice that they're going to connect right where these arcs overlap. When I do that, I get an exact match of my original triangle, no matter what. In fact, even if I connect down here at this other intersection point, I'm still going to get an exact copy of my original triangle, just a mirrored reflection of that. And it doesn't matter if I change my shape, completely altered, shape of my original triangle. Still, no matter what, if I copy all three sides, the length of all three sides, I'm only going to get that exact same shape copied down here. So side, 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 or SSS, is one possibility for a shortcut. In other words, I don't know anything about the angles, but I know if all three sides, corresponding sides, match up, I know I have congruent triangles. Our next shortcut is side angle side. So for this one, if I know two sides and the angle that's in between, that's very important, that the angle is in between my two sides, that I know, I can say that the triangles are congruent. And if we click on this GeoGebra link, pull that up, here's SAS. Here on this one, again, I've copied this green side and the red side. So the green is a match, the red is a match, and I've copied this angle that's in between my blue and my red line here. So this is a side angle side copy. The third side is free to grow or shrink as I need. So this length here, if I adjust it so that it matches the same angle, you'll notice we get an exact copy again. And it doesn't matter how I change my original shape. Again, if I match that angle and these two sides are the same, we're always going to get an exact copy of our triangle. All right, so far we got side, 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 and side, angle, side. Our third shortcut is angle, side, angle. So this time we have two copies of our angles, and in between those two angles, we have a copy of one side. And we have a GeoGebra that you can click on and play with. So if you click on that, you'll open up the ASA congruence. And here we have a triangle, and I've only copied the one side. This green side down here is a copy. Okay. And I've copied the two angles here on the outside of the side I copied. So these sides here are allowed to rotate and grow. But if I line them up with my angles, and then actually shorten them to intersect, you'll see I'll always end up with a copy of my original triangle. Doesn't matter, I can change the shape of my triangle completely. Totally different triangle shape here, but if I line up those angles, I'm still going to get an exact copy. All right, our last possibility kind of gets derived from the previous one. So if we have two matching angles, we actually know the third one is also equal as well, because all the angles inside of a triangle have to add up to 180. So if you got two that match up, the third one also is going to match up. So our third possibility is angle, angle, side. So this time we have two angles, and our side is not in between our two angles. but we still should be able to make that work. Okay. So once again, I've copied one side and two angles that are not in on the side is not in between the two angles. So let's go ahead and line up. So let's create one side that lines up. Okay. And then you can see here this angle is not quite hitting to make a triangle, so I got to shorten this leg up a little bit till it lines up. And then I can take this third side and line up, and we can see we're going to make an exact copy again. So it's a little trickier, but it still works. And those are our four possibilities for shortcuts. We got side, 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 angle, side, angle, and angle, angle, side. And here they are all together. So let's do some practice problems. So our directions are going to be identify, if possible, which method proves the two triangles congruent. Now, there's a few clues that we can use, a few shortcuts, not necessarily shortcuts, but a few clues. For example, if we have two triangles that are sharing a side, we can mark that as a congruent side. Okay? If they're sharing the same side, it's the same for both. And now I'm just going to go through and label. If I have a tick mark, I'm going to put that as a side. If I have an angle mark, I'm going to put that as an angle. So that's a side, that's an angle, and that's a side. So my angle is in between my two sides. Same on the other side of the triangle there. So that is SAS and SAS. So those are congruent by SAS. My particular favorite congruence. Why? Because it's got SAS. All right. Next one, we've got a shared side for number 2. So I'm going to go ahead and mark that. Now, they've already used a single tick and a double tick. So I'm going to use 3 tick marks there. And now, they don't have any angles, but I do have a side here, and a side here on the top triangle, and then a side and a side and a side. So what I have is SSS. So those are congruent by SSS. Now number 3 doesn't have any shared sides, but it does have vertical angles. So we always mark vertical angles. Okay. So now here's one pair of angles marked. There's a side. Oops. There's an angle. Angle, side, angles. So that is ASA. Number 10, got a shared side in the middle. Mark that. Here's an angle. There's a side, there's an angle. So this is ASA again. Number 11, I do again have a shared side. But we're going to run into a little bit of problem here. So here's my angle. Here's a side, and then here's another side. Same thing over here. Here's my angle. Here's my side and my side. So in our list here, we do not have a SSA or an ASS. That is not listed as a possibility. And in fact, that is not a possible proof, which we'll look at in our next lesson. So for these ones, we are going to say not congruent. So if you run into an SSA or an ASS, that is not a congruent pair of triangles. And then our last example here, go ahead and mark our shared side. And then I've got an angle, and a side, an angle, and a side. So that is AA All right, and that's the end of this lesson.